So basically, in the video, I explain how having multiple bodies like this requires you to to check every single collision with every single body, and that's bad because it's n elevated to the power of 2 complexity, and it's slow and it sucks.
Yes, it does.
What you can do is this. We still have. Why is it so big? Wait. Let's say we have some bodies. We can just create a grid like this. It's horrible, but you get the point. So you have to choose obviously where the grid starts and where it ends. So it's not an infinite grid. You have to have a begin and a end vector 2, and you have to choose a width and a height for the cells.
Yeah, but for the grid itself, you could just use a double-ended queue, and then you can have an infinite negative and infinite positive.
You could do that, but it's kinda slower than using a fixed array, because getting and setting a fixed array is very fast in C++. But obviously, if you want to trade some of the speed for the flexibility of an infinite grid, you can do that. So anyway, when you have the body, in the body class, you store in a vector of pointer to cell all the cells the body is currently occupying. For example, if we consider this red body right here, what we do is take the vertices positions, and we divide the first vertex by the width of the cell sides. So it's gonna be 0, 1, 2, 3, and we get
and then we get an integer of the grid it's in.
Okay, then we do the same for the other vertices. So you get the point, right?
Yeah.
What you do then is you run a for loop starting from the first cell of the top left vertex to the last cell of the bottom right vertex, and every cell you touch in that for loop is going to get added to the body is cell pointer vector.
Right.
So when you need to check collisions, to generate the collision pairs, you simply take those 6 pointers. You get the bodies from those 6 pointers, remove any duplicate, and basically this won't be touched, this won't be touched, this won't be touched. But if there was a body here or here, they would obviously be taken into account for collision detection.
So I guess the most optimal way of doing this is to have each cell be the size of the biggest body.
Actually, you kind of have to play around with that, because the cell size can make or break the whole thing, honestly. If you have a variable bodies of very variable size, you'd better use a quad tree, which is another special partitioning structure.
Yeah, I've heard of quad trees, but they're not. They're really complex to implement, and you're extremely limited when using them.
Exactly. So I prefer the grid, even if having a variable size can, I don't know, lower the performance a bit. So anyway, another thing to consider is that if you have, make me do the grid in just a second. If you have a body that's very big, you cannot obviously always clear the vector cell pointers and then refill it every frame, because that's gonna be 12 pointers added and removed every frame, and that's gonna be slow. So what you do is simply store as always, the position of the vertices, and you check if one of the vertices has changed its own cell. So if even a single one has done that, you obviously have to recalculate. But if the body didn't move at all, there is no need to touch the internal cell pointer vector. You understand what I mean? So that's
Yeah, I do.
quite fast. I do have an implementation in SSVSCollision, but it's templated and with inheritance, so it's a little messy. But you can see how it works basically. So if you look at the what did I send you? The grid header file.
Yeah.
You see that the cells are
Yep.
stored in a vector of cell, and they are owned. They are pointers owned
Yeah.
by the class, so they need to be deleted when the class is when the instance of grid is destroyed. Then I have you can see inline into get index. Basically, you give it a point in the space in the word, and it gives you the cell index. It's just a division by the cell size. You see it?
Yeah, but you don't need to get the index.
Now if you
Oh,
get
this is the grid,
into
right?
the
Sorry, I thought we were
grid
looking at the
info
cell.
header, which is in the same folder. Grid info header.
The what? Hold on.
So you can see that the grid
Grid
info
info. Okay.
is basically a way to abstract the internal representation of the vector of cell pointers in the body. So instead of having the body have a vector of cell pointers, the body has a spatial info base, which then every single spatial partitioning method inherits from. So if in the future I want to implement a quad tree, I simply make the quad tree info inherit from spatial info base, and then it can work with the current system. So basically every body stores its own instance of grid info. Understood? It's just an abstraction. So in the grid info we have a reference to the grid, obviously, and then we have the vector of cell pointers. That's what I was talking about before. We also have start x, start y, and x and the y, which are the position of the indexes better of the vertices of the body. And then we have the same things but with the old prefix. So what I do is I store the previous frame indexes in the old start x, old start y, and all the etc. variables. And if one of them is different from the new cell index, I recalculate the cell pointer vector. So it's much faster than always clearing and recalculating the vector. Then the last interesting thing is in the source file. Let me give you the link. So in the calc edges function, I basically get the new vertices indexes. So I do this kind of min max thing with all the shape and shape, but it's not really needed. It's for safety, to get every possible situation, even when for a single pixel the bodies collide. But what it does is basically get the vertices indexes. And the other thing I wanted to show you is calc cells, which is the for loop, the bidimensional for loop that gets the cells from the grid and pushes them back in the cells vector, line 47. And what it does, it also gets the pointer to the cell's internal vector of body pointers, so it's a little faster when iterating over the bodies, and that's line 52. So queries is a vector of pointers to vector of bodies. It's hard to follow, but instead of storing only the grid, you store the pointer to the vector inside the cell, so that you do not have to dereference a pointer 2 times, and you can dereference only once. It's a little faster. In the line 61 get
I
bodies
see.
to check, basically you just fill the vector of nearby bodies with the bodies taken from the queries, so from the adjacent cells basically. And to avoid duplicate collision checks, I just do a contains check that basically loops through the whole vector and checks if the body already exists. Because it's a pointer, it's quite fast. I would like a better solution, but using a set or removing duplicates at the end, it's slower. So this is the fastest solution I found.